Problem number 4. A car starts moving rectilinearly, first with an acceleration of 5 meter per second square, the initial velocity being 0, then moves uniformly and finally decelerating at the same rate till it stops. The total time of the journey is 25 seconds and you are also given the average speed during the whole interval is 72 km per hour. Calculate the time for which the car was in uniform motion. Okay. So we have a problem in which the car is going along a straight line. So if you want to visualize what would be the motion of the car, so say if the car is starting the motion at t is equal to 0, okay, like this. So the initial velocity is 0 and say it is starting at a point O and it goes up to a point A under acceleration of how much? 5 meter per second square, after which it moves with a uniform velocity covering some distance say till B, and finally there is a retardation, that is acceleration opposite to velocity of the same magnitude 5 meter per second square, and finally the car comes to halt, the stop. Correct? So this will be the visualization of the motion of the car. If you want to visualize what will be the motion of the car, it would be something like this. Correct? Okay. Now see, we want to solve this problem. You are given the average velocity of the whole interval, 72 km per hour, and you are also given the time of the journey, that is how much? 25 seconds. So with these two information you can find the displacement, because we know the basic formula, the average velocity is equal to the total displacement divided by the time interval. And we can solve this problem both by mathematical approach as well as by graphical approach. So we will go for the graphical approach, and we know when we make VT graph, so the basic fundamental tells us the slope of VT graph gives the acceleration and the area under the VT graph gives you the displacement. Okay, these are the fundamental things which we have learned in kinematics. So we know when acceleration is constant, the VT graph is a linear graph. So if I am plotting VT graph, so first the car is accelerating at 5 meter per second square. That is a constant acceleration and the initial velocity is 0. So if here I am plotting V in meter per second and here I am plotting T in seconds. So according to the problem, the car is starting from rest. So at T is equal to 0, the velocity will be 0. Then it is accelerating at a uniform rate. So since the acceleration is uniform, the first segment of the graph will be a straight line going upward. Okay, and say this velocity is V0. And say this interval is how much? Say delta T0. Okay, this is uniform acceleration. After which the car is traveling at a constant velocity. So this graph would be a horizontal line suggesting there is no change in the velocity. Correct? And then the car is finally coming to rest, having retardation of same magnitude. Now when it is having a retardation of same magnitude, can we say the inclination, the slope, magnitude of slope of the graph will be same? Because slopes gives you the magnitude of the acceleration. So here it will come down and this rise is same. So run is same as we have seen in the fundamental lectures. Since the inclination is same, so this is the graph of uniform retardation. So if this time is delta T naught and the acceleration is mod of A1 say, and the retardation has a modulus of A2, and in the problem it is given modulus of A1 is modulus of A2. So both these steepness will be same. So for the same rise we will have the same run. Correct? So this will also be what? Delta T naught. Okay, and you are given the total time interval. Say the total time is T. So the interval for the constant velocity would be t minus twice of delta t naught, correct? This is the time interval for which the car would be moving with constant velocity. Okay, so this is A, B, C. Okay, now we don't know what is V naught, but we can apply the basic geometry of slope and we can find V naught, because you are given the acceleration here is how much? 5 meter per second square. This is given as 5 meter per second square, and we know the slope of V graphs gives the acceleration, correct? So in this time interval delta t naught, this value is how much? V naught, and the acceleration is 5 meter per second square. So this will give you the slope, and slope is equal to rise by run, so that is V naught by delta t naught. So you'll get V naught by delta t naught as 5. So you will get V naught as what? 5 times of t naught. Got it? So this is the value of V naught in terms of t naught, which is coming as 5 times of t naught. Got it? Okay. So this is a graph we plotted as a VT graph, which is symmetrical on both sides because the magnitude of acceleration is same as the magnitude of retardation. So in the problem you are given the average velocity is 72 kilometer per hour, that is 72 into 5 by 18, that is 20 meter per second, correct? And the total time of the journey is how much? I guess it is given how much? 20 seconds? 25 seconds, something like that. In the problem it is given 25 seconds. So the total time of journey is given to be 25 seconds. So you can find the displacement from these two basic things. So we know the average velocity is what? The displacement upon the time interval. So you'll get 20 is equal to displacement upon 25. So therefore the displacement will come to be 25 into 20, that is 500 meter. Okay, so this is the value of the displacement which we are getting. So the displacement of the whole journey of the car is 500 meter, that we got from the basic information of average velocity and the time interval given in the problem. Okay, now we know the fundamental. When we plot a VT graph, the area of the graph bounded with the time axis gives you the displacement, correct? The area of the graph bounded with the time axis gives you the displacement. So if graphically I need to find the displacement, I need to find this area, and the figure is the trapezium. So this area will give you what? This area will give you the displacement, and already you got the displacement, which comes to be 500 meter. So now what is the skill we need to employ? Find the area of this figure trapezium and make it equal to 500 meter, because the area will give you the displacement. And we know the area of trapezium is how much? Half. The area of trapezium is half the sum of parallel sides multiplied by the height, that is the perpendicular distance between the parallel sides. So you'll get half. This side is your OC, this side is what? AB. These are the parallel sides multiplied by the height, that is how much? You can take this height, which is equal to V naught. Okay, so therefore the area comes to be half. Now what is your OC? The total time of travel, that is T. What is your AB? This much, the time for motion with constant velocity, T minus 2 times of delta T naught. And V naught we have to keep in terms of T naught. So already we have seen V naught came to be how much? 5 times of T naught. So this will be 5 times of T naught. So this is coming to be area, and this must be equal to what? 500 meter, which is obtained by the basic knowledge of the average velocity and displacement. Now the value of t is given to be 25 seconds. So put the value of t, so you'll get half 2t minus 2 delta t naught into 5 t naught is 500, and this will be 100 and I'll get half. 2 into t means 50 minus 2 delta t naught into delta t naught is equal to 100, and now I will cross multiply, so I'll get 50 into delta t naught, or you can also divide by 2. So I'll get 50 into 50 by 2 is 25 delta t naught minus 2 by 2 is 1, so delta t naught square is what? 100. Okay, this is the equation we are getting. So we are getting a quadratic in delta t naught. So this equation is coming to be, if I'm just for the convenience say I'm putting this as a positive quantity, so delta t naught square we are getting a quadratic minus 25 delta t naught plus 100 is equal to 0, and it is a quadratic in delta t naught, so I can compare it with the standard quadratic form a delta t naught square plus b delta t naught plus c is equal to 0. Okay, so what is a? 1, what is b? minus 25, and what is c? 100. Now you can apply the quadratic formula and you find the value of delta t naught. So delta t naught will come to be minus b plus minus b square minus 4 times of 4 ac divided by twice of a. So minus of minus 25 will be 25 plus minus 25 square minus 4 into 100 divided by twice of 1, that is 2. So I'll get 25 plus minus 625 minus 400 divided by 2. Got it? So you'll get delta t naught as how much? 25 plus minus, that will be 225 root divided by 2, that is 25 plus minus 15 by 2. So we'll get the two values of delta t naught, 25 and 15, that is 40 by 2, 20 seconds, and 25 minus 15, that is 10 by 2, 5 seconds. Okay, so basically we are getting two values of delta t naught. Got it? Now we have to think either both values are acceptable, or one is acceptable, or none are acceptable. So see the first thing, from the basic of the kinematics we know the value of instant of time, the time coordinate can be negative. A negative value of t denotes an event occurring before t0. But the time interval can never be negative because time flows forward. So the time interval can never be negative. However, we are not getting any negative value of the time interval. So that logic cannot be applied here to suspend any value. Had any of this value would have been negative, then that would have been suspended on the logic that time interval can never be negative, but here both the values are positive. So the logic that time interval can't be negative has no significance in this case as far as this time interval is concerned. Okay, now let's come to the problem. Delta t naught can't be negative. Is there any other time interval too in the problem? Yes, this is the time interval in which the particle is moving with a constant velocity. How much? The time interval is capital T, the total time, minus twice of delta t naught. And we know the time interval can never be negative, correct? So this interval need also to be non-negative. So for constant velocity interval, you can say this minus 2 delta t naught must be non-negative, that is greater than equal to 0. So 2 you will get t must be greater than equal to 2 delta t naught. So delta t naught must be less than equal to t by 2. So you are getting a maximum value of delta t naught which is physically acceptable. T is given how much? 25 seconds. So delta t naught must be less than 25 by 2, that is 12.5 seconds. So we cannot have any value of delta t naught exceeding 12.5 seconds, because if it exceeds 12.5 seconds, then this interval will come negative, and the time interval can never be negative, time flows forward. So the maximum value of delta t naught is how much? 12.5 seconds. Any value coming above 12.5 seconds will not be physically acceptable. So we got the two answers. What are the answers we got for delta t naught? One is 20 seconds, one is 5 seconds. Now 20 second is greater than the maximum value 12.5 second. So this will not be physically acceptable value. So the answer that is physically acceptable is 5 second. Okay. So we got the value of delta T naught as 5 second. Got it? Therefore delta T naught is coming to be 5 second. Now delta T naught is coming to be 5 second. The demand of the problem is not to find delta T naught. We have to find the time interval for which the particle is moving with constant velocity. So basically we have to find this interval, correct? We have to find this interval, and this interval is how much? Capital T minus 2 delta T naught. So what do you think will be the answer? So time interval for constant velocity, time interval for constant velocity, simply you can apply, since you got delta T naught, the physically acceptable value as 5 second, and the time interval for constant velocity is how much? T minus 2 delta T naught, and T was 25 minus 2 into 5, so you will get 25 minus 10, so answer is 15 second. So the answer to the problem is 15 second. Okay, got it? So this is the answer to the problem, 15 second. So see, the problem was done very easily applying what? The graphical approach. And the basics that the slope gives the acceleration and the area gives the displacement. Got it?